Okay, we are now going to finish the Calc 2 video by talking about improper integrals. Integrals where you might be integrating over what I will call trouble points. For example, if you were going to try to integrate from 0 to 2 of 1 over the square root of x dx, 1 times dx is just dx, you can't really integrate by 0. You can't, here, if you try to do this, let's see what would happen. You have x to the negative a half dx. You add, well, actually, okay. You can't integrate it the way it is because you're passing 0. You can't let x be 0 in the denominator. Even if I went from negative 5 to 2, you can't go by 0. You can't even start with 0. So what you're going to do is you're going to integrate instead of 0 from 0 to 2, you're going to integrate from k to 2. And then you're going to take the limit as x approaches 0 from above. Why from above? Because you're going from 0 to 2. You're always going to be above 0. If you're not 0, you're just above it. You're getting closer and closer to 0 from above. If you are integrating from negative 2 to 2, maybe we'll do that problem next, and that will be slightly different. Okay, so now we basically want to do this, and at the end we take the limit. So now we just keep writing limit. How do you integrate dx over square root of x? Well, remember, square root of x is x to the half. Well, when you bring it to the numerator, it becomes minus a half dx from k to 2. And then you add 1 to the power, you get a half, and you divide by a half. You divide by 1 over 2. And you evaluate it from k to 2, except you say limit as k goes to 0. Until you take that limit, you better keep writing it. K goes to 0 plus. When you plug in 2, you get 2 square root of 2. Remember, that's just square root of 2. Excuse me, that's square root of x. And don't bother dividing by 1. Limit as k goes to 0 plus. Minus, now you plug in k. You get 2 square root of k. And as k goes to 0, this whole piece goes to 0. This just stays 2 square root of 2. That just stays 2 square root of 2. Alright. Let us actually do this problem once more with that one minor change that I mentioned. Instead of going from 0 to 2, we're going to go from negative 2 to 2. Actually, we can't, because you can't plug in negative numbers in there. You can't take the square root of negative numbers. Okay, so we will do a similar problem that illustrates what I wanted, or what I want. Instead of having square root of x on the bottom, we'll just put x. We want to integrate dx over x from negative 2, say, to 3. But there's a trouble point there. You can't have 0 on the bottom. So if you want to go from negative 2 to 3, you can't have 0. So you go from negative 2 to as close to 0 as you can get, and then you go from just above 0 to 3. That is, you integrate from negative 2 to, say, k of dx over x. And you say that k is approaching 0, but from below. That is, it won't be above 0. that was this region. Plus, now we can use k again. You can go from k to 2, and then you take the limit that k goes to 0. It's really, really close to 0, but from above. And just keep writing limit. The limit as k goes to 0 minus, well, this integral is ln of absolute value of x from negative 2 to k plus the limit as k goes to 0 plus of ln of absolute value x from k to 2. Now infinity plus infinity is nonsense. Well, actually it's infinity. Infinity minus infinity, excuse me, once one of these evaluations is infinity, you're done. The answer does not exist. There's no answer. Okay? We figure this out, we figure that out. If both of them are real numbers, we will add them. Okay, so we get the limit as k goes to 0 minus of ln of absolute value of k minus ln of absolute value of negative 2. That's the first sum, first term, plus the limit as k goes to 0 plus of ln of absolute value of 2 minus ln of absolute value of k. So this is the limit as k goes to 0 minus. You can say it's ln of the absolute value of k over negative 2 or 2. It's this limit plus the other limit, which is the limit, the other term, which is the limit as k goes to 0 plus of ln of 2 over k. I'll put the whole thing over in absolute values. Now, it doesn't matter whether you plug in a negative number or a positive number because you're taking the absolute value. This first answer is infinity. Actually, it's negative infinity. The ln graph gets closer and closer and closer to negative infinity as the x value gets closer and closer to 0. And negative infinity plus the other one's also going to be negative infinity. The answer does not exist. No answer. Okay, so that one did not exist, but most importantly, 0 was in the middle of the interval that we were integrating over. And that's not much 0, but the trouble spot was in the middle, so we had to use limits 2 times. Suppose you want to integrate from 3 to 4 of dx over the square root of x minus 3. Well, you can't take the square root of 3, take away 3 in the bottom. You can't divide by 0. So what you have to do is say, you know what, I'm going to take the limit, say as k goes to 3, but from above. Why? Because when you go from 3 to 4, you're never below 3, so that's why it's 3 plus. Integral. Now, I'll just write it as x minus 3 in the top to the negative 1/2 dx. Well, if I call that u, why? That would be du. So you have u to the negative 1/2 du. But I know that integral. I know the integral of u to the negative 1/2 du. I add 1 to that power, I get u to the 1/2, and I divide by 1 over 2. So I get 2 square root of u. That is 2 square root of u, which is x minus 3. Okay, so I get 2 square root of x minus 3 from k to 4. I definitely should have written that down. From k to 4. So it's the limit as k goes to 3 plus. First I plug in 4. 4 minus 3 is 1. The square root of 1 is 1. 2 times 1 is 2. Minus, now I plug in k. Square root of k minus 3. Well, the limit of 2 as k goes anywhere, whether it be 3 or not, is 2. And the limit of this product is the limit of the first, which is 2, times the limit of the second. The limit as x goes to 3 plus of this is 0. It had to say 3 plus because the limit as x goes to 3 from the minus, from below 3 of this makes no sense. Because if you're less than 3 and you take away 3, you're negative. You can't take the square root of a negative number. But if you're a little bit more than 3 and you get closer and closer to 3, this gets closer and closer to 0, but positive values. 0.0001, positive 0.0001, etc. So the square root of 0 is 0. 2 times 0 is 2, is 0. And then 2 minus 0 is 0. This is 2 minus 2 times 0, which is 2. The answer to that integral is 2. Sometimes you cannot write limits and just plug in the upper and lower limit blindly, and you know what? You'll get the right answer. But you also know what? You will not get much credit on your exam. Definitely not on my exam. The integral from 0 to 7 of 1 over x minus 1 squared dx. Well, you have problems at 1. You can't let x be 1, else you'll be dividing by 0. So you have to integrate from 0 to kind of 1. Call it k. But then let k go from 1 to below. That is, when you're integrating from 0 to 7 and you have to pass 1, well, you go 0 as close to 1 as you can, plus, then from just above 1 to 7. Here is just below 1. So you're going from 0 to just below 1 of the function that you were always integrating, plus, now you want to integrate from k to 7, really from just above 1. So you call it k, but then you say k, goes to 1 from above. Gets closer and closer to 1. Up to 7 of the same integrand. Okay, so now how do you integrate dx over x minus 1 squared? Well, you should rewrite it as x minus 1 to the negative 2 dx. If I call that u, well, that's du. So you take u, and the integral of u to the negative 2 du is u to the 1 more than negative 2 divided by that number. A positive over a negative is negative. And instead of putting x minus 1 to the negative 1 on top, you put it on the bottom as x minus 1 to the 1. And here you have a 1 on the top, a negative 1 on top. Okay, so this is equal to the limit as k goes to 1 minus of negative 1 over x minus 1 from 0 to k plus this limit. The limit as k goes from 1 from above of negative 1 over x minus 1 from k to 7. The only thing is I hate that minus sign. It will drive me crazy to deal with that minus sign. There is absolutely no reason to do that. Probably 9 times out of 10, I would mess up. fortunately, I can get around it. If I interchange those limits, then I can change that sign. And after all, I'm taking the limit of that. And that's the same as 1 over x minus 1 from k to 0. And as long as I'm taking the limit of the same thing or something that's equivalent to that, it's okay. I'm taking the limit of this. So I can play games with this as long as I don't change the value. That is, I can change the way it looks. I want it to look like 1 over x minus 1. Well, then I better change the limits. Okay, let's look at this limit. So limit as k approaches 1 from below. First I plug in 0. And I get negative 1. Minus, and then I plug in k. 1 over k minus 1. Plus, what's the limit of that? Plus the limit as k goes to 1 plus. First I plug in k. I get 1 over k minus 1 minus and then I plug in 7. I get 1 over 6. Okay. The problem is, in any one of those limits, we have a problem. If I plug in, so it's the limit of this, which is negative 1, minus the limit of this. But that's undefined. That's undefined. Because anywhere near negative 1, excuse me, if that's anywhere near 1, even if it's a little bit less than 1, when I take away 1, it's close to 0. 1 over 0 is undefined. The answer is, it does not exist. You don't even have to bother doing that. But if you did, you plug in a number really close to 1, but a little bit more, you're still going to get close to 1 over 0. It doesn't exist. Now, just for the record, the integral was 1 over x minus 1. If you just went from 0 to 7, and you know me, I would change it to 1 over x minus 1, go from 7 to 0. When you plug in 0, you get minus 1, minus. When you plug in 7, you get a 6. So the answer will be negative 1 and 1/6, which is negative 7/6. And you'd be wrong. You'd be wrong. Okay, you cannot integrate over an undefined point. You can integrate over it, and then you can integrate just above it. You can integrate up to just below a bad point. You can integrate starting from just above a bad point. That is using limits. But you can't integrate through a bad point. Now, here's an improper integral. Suppose you want to integrate 1 over x squared dx from 1 to infinity. Well, this is the integral of 1 over x squared dx. Well, that's the integral of x to the negative 2 dx. You add 1 to the power, you divide by that number, you get negative 1 over x from 1 to infinity. Well, I clearly know how to plug 1 in here, but how do you plug infinity in there? Well, you can't. So what you do is you integrate dx over x squared from 1, from that limit, say to k. But then you say, you know what? I'm going to let k approach infinity. And as we do, so it's the limit of that, limit as k goes to infinity of this. But we just said that's negative 1 over x from 1 to k. I really do hate that minus sign. I'm going to take the limit, not as x, but as k goes to infinity of 1 over x. But instead of going from 1 to k, I go from k to 1. So this is the limit as k goes to infinity of 1 over 1 minus 1 over k. This, of course, is 1. As k goes to infinity, 1 could not care less. It stays 1. Minus, but 1 over k cares about what k is. If k is 7, it's 1 over 7. If k is 30, it's 1 over 30. If k gets bigger and bigger, it's 1 divided by large numbers. You take one piece of candy, divide it by 10 billion people, they each get 0 or close to 0. 1 minus 0 is not 0, but rather 1. The answer is 1. Okay, here's a case where we got an answer. Okay, if one of the limits is infinity or minus infinity, you have to, one of the limits of integration is plus or minus infinity, you have to take limits. Yeah, suppose you have dx over e to the x minus e to the negative x. You want to integrate this from 0 to infinity. Well, you can't. You can integrate this same function. You can integrate it from 0 to k, and then let k go to infinity. Now, other than the limits, you can change this any way you want. You can make use of substitutions, etc. But in the end, k has to go to infinity. Now, how you integrate this one, that's probably interesting. I mean, maybe the first thing I would do is I would let u equal e to the x, so then du will be e to the x dx. Now, if I divide both sides by e to the x, I get du over e to the x equals dx. But e to the x is u. That is, I did get to write du, I meant to say dx, just using u's. Okay, the bottom, why, that's u, and that's u to the negative 1. Why? Because e to the negative x is equal to e to the x to the negative 1. Negative 1 times x is negative x. So you get u to the minus 1 or 1 over u. Okay, so I didn't mean to write an e here. E to the x is u, e to the minus x is u to the minus 1, and dx, that's du over u. So you have well, let me do the bottom. You have u minus 1 over u, and the numerator is du over u. So what you have is du over u squared minus 1. And let me just write here that u was e to the x. Now, the reason this one is okay is because now it's a trig substitution integral. Okay, you make up the triangle. That's why it's trig sub, because he uses a right triangle. U is being squared and 1 is being squared. In front of the u is a plus, so the u goes on the top. In front of the 1 squared is a minus, so 1 goes on the side, one of the legs. And the square root goes here. Well, and here's v. The secant of v is u over 1. Taking differentials because we want to get du. Secant v, tangent v, dv is du. So I have du. Now I need u squared minus 1. Well, the tangent of v is the square root of u squared minus 1 over 1. Now if I square both sides, tangent squared of v is u squared minus 1. Okay, so du is secant v tangent v dv all over tangent squared of v. Well, one tangent in top kills off one of the tangents in the bottom, so I'm left with the integral of secant v dv over tangent of v. And you know what? I hate anything other than sines and cosines. Secant in the top, secant v in the top is cosine v in the bottom. Okay? Tangent in the bottom is sine of v over the cosine of v. Let's not forget dv. So this cancels out, and sine in the bottom is really cosecant v on top. Okay, so let me write this down. Secant of v is u. So we made those two substitutions. So I could erase some stuff. Let me try to keep the triangle in case I need it. Okay, so we are left with the integral of cosecant v dv. Why, that is negative ln of the absolute value of cosecant v plus cotangent v plus a c. So this is negative ln. Now, what is cosecant v? Cosecant is hypotenuse divided by opposite. It's u over the square root of u squared minus 1 plus the cotangent of v, which is 1 divided by the same thing. That is, they have the same denominator, so let's just write it as one single denominator. U squared minus 1 plus c. Okay, now all I have to do is say that u is e to the x. So u here is e to the x. And u squared would be e to the 2x. U squared would be e to the 2x. E to the 2x. And there is no plus c because we want to take the limit of this. Okay, so I erased most of this, at least the middle part. It's called magic. And what I get is the limit as k goes to infinity of this, which has a minus in front. I'm going to ignore the minus, so it's ln of e to the x plus e to the 2x minus 1 underneath the square root sign over e to the 2x minus 1. And we are going to integrate not from 0 to k, because I ignored the minus, but rather from k to 0. Okay, now we could erase the bottom. And we plug in the upper and lower limits. We clean it up, then we take the limit. Okay, so this is the limit as k goes to infinity of ln of, you plug in 0, you get e to the 0, which is 1, plus e to the 2 times 0 is e to the 0, which is 1, minus 1 is 0, the square root of 0 is 0. Oh. Sorry, folks. Even from the very beginning, you couldn't plug 0 in. Okay, so we didn't do anything. We can clean up our little typo. We can clean up our little problem. We can clean it up. It's the integral from, say, L to K dx over e to the x minus e to the minus x, and we are going to take the limit as k goes to infinity and the limit as L goes to 0 from above. Okay, so one other thing I want to say is when you have L, okay, do I want to do that now? Yeah. You could interchange when it comes to LNs. You can take the limits first and then take ln second. But remember, we also have the limit of this L going to 0. It doesn't matter which we write first. And we should have L here. Okay, so this is equal to ln of the limit. So first I plug in L. So I get e to the L plus e to the 2L minus 1 under a square root sign divided by e to the 2L minus 1, and we take the limit as L goes to 0 plus. Above I wrote infinity, excuse me. So just because you see a limit of infinity, don't think, oh, I don't have to worry about any other values. Nonsense. Okay, minus, actually, actual value of this, minus, now I deal with the other limit. The limit is k goes to infinity, and I plug k in. I get e to the k plus e to the 2k minus 1 underneath the square root sign divided by e to the 2k minus 1. Now, any one of these limits does not exist, we're done. ln. The first limit will not exist because if L goes to 0, e to the 0 is 1, and 1 minus 1 is 0. It does not exist. The whole thing does not exist. And ln of I don't know, it does not exist. There is no answer to that problem. There's absolutely no answer to that problem. And I just want to see what the author says about this problem. Unfortunately, I can't find the problem again. Aha, I found it. Okay, so this pretty much finishes the Calc 2 video. I hope you enjoyed it and that it's helping you out a lot. I obviously put a lot of time into this. 7:17. One more moment. Okay, would you believe that they say they get an answer? Oh, but I did it differently. They actually had a plus right there. They had a plus right there. So it doesn't exist, and that finishes the video, and good luck. Thank you.